Hello students, welcome back once again to the online lectures over design of pre-stressed concrete structures. Okay, so we were discussing about the shear strength of pre-stressed concrete beams. Okay, and in the last session we have seen the types of failure in the types of shear failure in pre-stressed concrete beam. So with respect to that, we are going to solve the examples to calculate the shear strength of pre-stressed concrete beam, that it may be flexural shear strength or web shear strength. Okay, so the problem is given like a bridge girder made up of a T section, top flange 600 mm by 230 mm, web 150 mm by 950 mm, and the span of the beam is 25 meter, and the effective pre-stress after all losses is 900 Newton per mm square. Tensile strength of the concrete is 1.6 Newton per mm square. Cross section area of cable is 2300 mm square. The cable is parabolic with 0 eccentricity at support and 650 mm at midspan. Okay, then estimate the ultimate shear resistance of the support section and maximum permissible UDL with factor of safety of 2. Okay, so here they are given the geometry of the cross section, that is it is a T section, it is a bridge girder, the geometry is T section, the top flange is size given, web is given, and the span of the beam is 25 meter, and the effective pre-stress in the cable after all losses is 900 Newton per mm square. The pre-stress is generated in the cable is after all losses, that is 900 Newton per mm square. The tensile strength of concrete is 1.6 Newton per mm square, and the cross section area of the cable is 2300 mm square, and the cable profile is parabolic with eccentricity at support is 0 and 650 mm at midspan. So we have to find out the ultimate shear resistance of the support section, and we have to also find out what is the maximum permissible UDL with factor of safety 2. Okay, what is the maximum permissible UDL, okay, that beam can carry with a factor of safety of 2. Okay, so according to the given detail, we have the sketch here. The flange is 600 by 230 mm, and the web is 150 mm thick and 950 mm depth. Okay, and as per the loading, the profile of the cable is parabolic. Okay, with the eccentricity at support is 0 and at midspan it is 650 mm. Okay, and we have to find out the W per meter with the factor of safety of 2. Okay, so we'll start with the solution now. So here I'll just note down the given data first. Okay, the given data are here. The span of the beam, apart from the section, span of the beam given as 25 meter. Okay, then FPE, that is effective pre-stress after all losses, is 900 Newton per mm square. Then area of pre-stress is given as 2300 mm square. Okay, and the factor of safety is given as 2. Then the tensile strength of concrete is, that is FT, is given as 1.6 Newton per mm square. Okay, the tensile strength here it is mentioned, it is the tensile strength of concrete is 1.6 Newton per mm square. Okay, so we have the given data and the sketch. Okay, so we'll start with the solution. So here we have to find out, first of all, the shear strength VCO and the W, both we have to find out the shear strength and even the maximum permissible UDL over the beam. Okay, then So here so before that I'll just would like to give a note. See, if cable profile is parabolic, or suppose it is linear, then the vertical component of pre-stress is added to VCO. So automatically what will happen? So therefore it will increase the ultimate shear strength. It will increase the ultimate shear strength. Means what will happen? See, suppose the cable profile is, if the cable profile is parabolic, so what will happen? So it will get two components, one is horizontal and one is vertical. Okay, so what will happen? So this will be PH and this will be PV. So what will happen? The shear whatever developed in the concrete, so this force plus the VCO total will increase the shear capacity, because this will also try to compress, and even we are providing the shear resistance in the concrete, that will also improve the shear capacity of the concrete. So we have to add the vertical component of whether it is the cable profile is linear, that is a triangular, or if it is parabolic, the whatever the vertical component is there, that we need to add in VCO. Okay, the design shear strength. Okay, so therefore I can write therefore the final ultimate shear strength, therefore the final ultimate shear strength is equal to VCO plus PV. So that is nothing but VCO plus P theta. Okay, so therefore VCO is equal to, it is mentioned in the code IS 1343, so that is 0.67 BWD square root of FT square plus 0.8 FCP into FT, to 0.8 FCP into FT. Okay, so FCP is equal to, again FCP is equal to P by A, that is direct stress P by A, so which is nothing but P is here, it is not given directly, so where P is here, the stress, effective stress into area of pre-stress. So here the P is the effective pre-stress into area of pre-stress. When the P is not given, if these things are given, so we can multiply effective stress into area, so we will get P. So that is P is, I will write here once again, FP into AP divided by area. Okay, so here FP is given as, here 900 into 2300. Fe is given as 900 and the area of pre-stress is given as 2300 divided by 600 by 230 plus 950 by 150. Okay. So we'll get VCO is equal to, therefore VCO is equal to, you get it as 0.67 into BW is 150 into D is total depth is 950 plus 230 into bracket of square root of, sorry, Ft is given as 1.6, the tensile strength of concrete, plus 0.8 into Fp is 7.38 into again 1.6. Okay, so we'll get VCO is equal to 410.92 kilonewton. So we'll get VCO is equal to 410.92 kilonewton. Okay. So here the total depth we have to take. So I'll just show it. See, the total depth is 950 plus 230. Okay, 950 plus 230. Then also PV is equal to, then the PV you have to find out, where PV is equal to P theta, where theta is equal to 4E by L. So E is given as 650. So 4E 650 upon L is 25 into 10 raised to 3. Okay, so we'll get that 0.104. 0.104. Okay. So therefore PV is equal to P into theta. Yes, PV is equal to P into theta. So again P is what? Stress. You can look at here, Fp into AP. So that is Fp into AP is 900 into 2300. That is Fp into theta is 0.104. So we'll get this as 215.28 kilonewton. We'll get this as 215.28 kilonewton. Okay. So then therefore the ultimate shear strength is equal to VCO plus PV. So VCO is 410.92 plus PV is 215.28. So we'll get total shear resistance is 626.2 kilonewton. So what does it mean? The concrete can resist a shear of 626.2 kilonewton, including the shear resisted by pre-stressing cable. Because of the shear resisted by pre-stressing cable, because the cable is parabolic, so it will also incorporate the vertical component of the cable profile, will incorporate to increase the ultimate shear strength capacity of the beam. So this is the shear resisted by the concrete and shear resisted by the cable profile. So total we will get ultimate shear resistance, that is 626.2 kilonewton. Then we have to find out the next one is ultimate load carrying capacity. Now ultimate load okay, so by equating shear force is equal to V. So we will equate shear force equal to V. So shear force is nothing but, we have a beam, with a load UDL. So what will be shear force? Shear force is nothing but the reaction developed here. So this will be WL by 2. So what will be shear force? Will be WL by 2. So because this will be W for a span of L. Okay. So shear force is WL by 2. So that is WL by 2 is equal to V. So V we have got it as 626.2. Okay. So therefore you will get WU from this. You will get WU from this. You will get so 626.2 into 2 divided by L is 25. So we will get 50.096. I will check here. Hmm? 50.096 kilonewton, okay, per meter. So this is the load the beam can carry with respect to the shear force, okay, but the working load as per factor of safety 2, as per working load, the working load as per factor of safety 2. So it will be, the W will be, so this is W, so now it will become WU. So we have to divide the load by factor of safety. This is the ultimate load, because here we can see W will be factor of, sorry, WU will be factor of safety into W. What will be ultimate load you will get when you multiply factor of safety to the working load. And when you want working load, what you have to do? The working load will be WU divided by factor of safety. WU divided by factor of safety. So WU divided by factor of safety is 2. So you get W is 25 kilonewton per meter. So this is the next. Okay, this is the final solution. That is 25 kilonewton per meter. Okay. So this is regarding the calculation of, so we got the shear strength. I can write V is equal to 626.2 kilonewton. Okay, so we got this and this. So we got the two solutions, that is one is V, one more is the shear, the ultimate load as 25 kilonewton per meter. Okay, thank you.